All right, so these were the questions from Quizizz. On here, the green is how many of us got it right, and the red is how many we got it wrong. So we're going to go through it. If you have one you want me to specifically look at, I'll go back and look at it. But for me, I'm going to spot check the ones we did really bad on. Okay? So these questions in general we're not very good at. Which of the following is true? So they give you this point, and it says, what can you say about the value of d squared y over dx squared? What does d squared y over dx squared mean? Second derivative. And what are we going to look for in a graph if we want to talk about its second derivative? Concavity. So looking right here at this point, what is true about the concavity right there? It's down like a frown. Concave down like a frown. Bless you. So if it's concave down like a frown, it's negative. When at the point, what's the second derivative? So that means what's the concavity at that point? Okay, that's what it's referring to. Okay, I know we weren't very good at those, but that's what it's asking. It should have been negative. Okay, let's look for another one we did poorly on. We're going to work through that. 10 misses here. Okay, this question was missed a lot first period as well. Given a graph of f double prime, which could be a point of inflection? So here's the thing I want you to focus on most. Point of inflection. Where, just regardless of a graph, what has to be true for something to be a point of inflection? Concavity changes, or in other words, f double prime changes signs. That's what we're looking for. F double prime changing signs. That is the definition of a point of inflection. F double prime has to change signs. Okay? So if this is a graph of f double prime, this is f double prime. That's what I want. I want to know when f double prime changes signs. What's going to have to happen on that graph for f double prime to change signs? Cross x-axis. It's going to have to go from being positive, so up here it's positive, and then all of a sudden it goes to negative. Okay, right there, there's a point of inflection. Okay, where else is there a point of inflection? Well, when it goes from here to there. Right there is a point of inflection. It changes from negative to positive. The other place it changed from positive to negative. Okay, so at 0 and A. So at A would have been my right answer. Questions with that one? This one is I know this question is on there. They love this question. I like this question. It's a good one. Okay, it's different, but it's good. Okay, we haven't done one specifically like it, so if you missed it, it's not the end of the world. If you got it right, that means you're thinking. Okay, it says the function f has a positive first derivative. What is true about a function if the first derivative is positive? Increasing. Okay, that's what that means to us. It is increasing. Okay, it has positive slope. That's what we got from that. Okay, it also says it has a negative second derivative. Concave down, what's another way we could say concave down? What's decreasing? The slope is decreasing. Okay, the slope is decreasing is another way to say concave down. Okay, and that's going to be the better way of saying it this time, and we'll show you why. Okay, so we need this thing to be increasing. That's the first thing. Which one of these choices is not increasing? C. It goes from 16 to 12 to 9 to 7. It's not C. Okay? In order for it to be concave down, in order to have a second derivative that's negative, the slopes need to be decreasing. Or in other words, the jumps that we're making from one to the next need to keep getting smaller and smaller and smaller. They need to decrease. Okay? So as I go from 7 to 9, I jump 2. And when I go from 9 to 12, I jumped 3. And when I go from 12 to 16, I jumped 4. Are those slopes decreasing? They're increasing. That function right there is concave up. It is accelerating, would be another way to think of. The second, it's going up faster. Okay, that's what you want to think about here. This graph right here, B, is concave down. It is decelerating. Okay, the acceleration is negative. Okay, whatever you want to think about it, that's what I like. All right, it goes from 7 to 11, so it jumped 4. And then it went from 11 to 14. Now it only jumped 3. And then went 14 to 6. Now it's only jumping 2. It's not speeding, or it's not increasing at quite the same rate. Does that make sense what we're talking about there? That's a good question. Okay, I guarantee you see that on the AP exam. Oh, go away. Number 12, we did this one the other day on Kahoot. Okay, we did this one on Friday last week. Yeah. Okay. Where does F have a point of inflection? We just talked about F having a point of inflection. What has to be true for the function to have a point of inflection? That was on that one. That was a different graph. It doesn't have to cross the x-axis. Concave up to concave down, or F double prime changes sign. That would be what I would suggest the definition that you want. Because when we make our number line, okay, when we do our second derivative number line, that's what we're looking for. If we put 0, it's got to change. That's what we think about with point of inflection. Okay, that's what we're looking for here. So I want the second derivative to change sign. Well, I have F prime. What am I looking for on an F prime graph in order to talk about F double prime? To go down one derivative, I need to talk about what? Slope. So I want to know when the slope changes sign. Where on this graph, where does slope change sign? At maxes and mins. Right here, it goes from up to down. So right there is a point of inflection. Here it goes from down to up. Right there is a point of inflection. -1 and 3 should have been our answers. What other ones do we want to look at? Anyone else that you're like, man, I wasn't quite sure on that one? So this one says F has the property that F prime, not this 11? Okay. You want me to do that one anyways? Okay. We'll do plenty. I mean, I'll go for the next 6 minutes here. F has the property that F prime, and F double prime are all negative. Which of the following could be F? Okay. So if F is negative, what are you looking for on an F graph for F to be negative? For F, just F to be negative. Below the x-axis. I'm not working with any derivatives. I just want to see where am I. I am below the x-axis. That is what an F graph would look like if it's negative. What would I want to look for to see an F prime graph? That's negative slope. An F prime graph is negative, means negative slope. Okay? And if I want an F double prime thing, an F double prime graph to be negative, concave down. So let's go through this. Are all of them below the x-axis? Yep, so these, all of them fit into that. Are all of them concave down like a frown? Yep, those all work. So the negative slope thing is going to be the deciding factor here. Which one of these graphs does not have negative slope throughout the entire function? A does not, because it goes from up to down, not A. C goes just up. It's just increasing. It's B. It has negative slope, it is below the x-axis, and it's concave down. Make sense, Pedro? All right, which one were you looking for, Antonio? Okay, so if we're talking about increasing or decreasing, if it says increasing, decreasing, if it says find the maxes and mins, if it said find the point of inflection, all of those different things, and they gave me a function, what am I going to do? Take the derivative. Okay, I'm going to take the derivative. So y prime here is going to be equal to 3x squared minus 6x. I took the derivative. Now what am I going to do? Okay, now what do I do? Equal to 0. Equal to 0. I'm going to factor out 3x. And my number line here, I'm going to take that information and put it on a number line. So my number line is going to use the numbers 0 and 2. That's what I get from this and this. Then remember, we're plugging in numbers. So I want a number between 0 and 2, like 1. If I plug in 1 into that, I get a positive answer. If I plug 1 into that, I get a negative answer. So when I multiply a positive and a negative, that answer would be negative. Okay, then I want a number bigger than 2, like a bajillion. If I plug in a bajillion, It's positive. If I plug in a bajillion, it's positive. When I multiply them together, it gets me positive. Plug in a number smaller than 0, like negative bajillion. Negative, plug in negative bajillion, it's negative. When I multiply a negative and a negative, it also gets me positive. So it is increasing. Okay, when y prime is positive, that means the function is increasing. So from negative infinity to 0, and from 2 to infinity, it's decreasing from 0 to 2. If this question was, where is the maximum on this graph? What would have to happen with the derivative in order for it to be a maximum? Change signs from positive, because you want to go from going up to going down, from positive to negative, so 0 is a maximum. What does that mean about 2, do you think? It's a min, because it's changing from negative to positive. That's a minimum. Any other ones that you want to look at? The mean value theorem one. So mean value theorem means average. This looks like the last one I'm going to get to. Mean value theorem means average. Okay, so I want to find the slope. So I want to use the points 2 and 6 as my 2 ordered pairs. I plug in 2. Anybody already do this for me? It's 2. What happens when I plug in 6? It's also 2. So my slope is 0. Okay, you can do slope formula. It's 0. Okay, then we're going to take the derivative of this thing. So the derivative is going to be 2x minus 8. And in order to find that value, I'm going to set it equal to the average, which was 0. Add 8, divide by 2, 4. Make sense? Okay. So, good review. I'll post the actual quiz on there again, so you can go back and do it again. Maybe not today. That's probably something I would save till like next Tuesday. Okay, don't watch this video beforehand. Wait till after you've done it. And then if you need it again, go back and watch the video to see what you missed. Okay, good stuff.